One moment here. Here we go. Okay. All right, so standard costs and variances. We're a little bit familiar with variance. We have done some work with, for example, budgets, and we looked at flexible budgets and how they compare to actual performance, as well as static budgets and how they compare. But we're going to go deeper into that kind of concept this week, where we figure out what our costs should be, what are the standards, look at the actual performance, we look at the difference between the two to see, is it favorable, meaning more profitable, or unfavorable, meaning less profitable. And that will include materials, labor, and overhead, primarily variable overhead. So we'll be looking at all those variable costs and how they differ from the standards that have been set. And that is called variance analysis, right? So as it says here, standard cost is established at the beginning of a fiscal year and also a standard quantity. So whatever it is that you're producing, you want to have an idea of how much material, how much labor, and how much overhead you're going to use. And then also, what is the rate for that material, that labor, and that overhead? Okay. That way you can then compare your actual costs with those standards and see how did we do. Maybe we ended up paying more per pound for the materials that we bought, but we used less material than we thought we were going to use. Both of those would be a variance from the standard. Okay. Now, I mentioned already, favorable means more profitable. Unfavorable would be less profitable. So when we're thinking about costs, what does that mean? If our actual costs were favorable, were they higher or lower than the standard? Lower, because that makes us more profitable. So if our costs are higher, that would make us less profitable. That would be unfavorable. I guess that was somebody else's phone. Funny how phones all kind of have the same sounds. Here's an example of a standard cost card. So if we wanted to, I think this is a coffee shop. Yeah, if we wanted to know what are our standard costs for a cup of coffee. Well, we know that production costs include material, labor, and overhead, right? And the fixed overhead is pretty much going to be what we expect it to be. So really, we're really just looking at the variable costs. All right, so with direct materials, if we say that for each cup of coffee, we use half an ounce of coffee grounds, and the cost to us is 50 cents per ounce, then we can just multiply the standard quantity times the standard cost for that material. And we see that for each cup of coffee, that's 25 cents worth of materials. Okay? Not counting the cup or the water, right? Just the coffee. And then how about the labor? Well, we've got a barista that makes the coffee. If it takes them a standard 1 minute to make a cup of coffee, it seems a little long to me, but I guess maybe if it's like a latte or something, it takes longer. And we pay them 20 cents per minute, which would be what, $12 an hour? That sound right? Let's do some quick math here. 20 cents per minute times 60 minutes in an hour. Yeah, so they're making $12 an hour. Not a lot of money, but per minute, that comes out to 20 cents per cup of coffee. That would be our labor cost. Our overhead, if it's based on the labor minutes and it's 5 cents of variable overhead per labor minute, Well, that would be 5 cents of variable overhead. And then there is fixed on here. If the fixed came out to 10 cents per minute of labor, that's 10 cents of overhead. So we just add that all up and we know the total cost to make 1 cup of coffee, including the material, the labor, and the overhead. Okay, now we know what our standards are. So now we can check our actual costs and see how they compare to these standards, right? And see, are the results favorable or unfavorable? Okay. Any questions so far? Pretty basic, right? Yeah. Oh, wow, an exercise already. Very good. Let's do this one. So this one has to do with labor. Yes, I'm gonna stop recording. Okay. So here we're making a cost card. That'll be like the one we saw for the cup of coffee, where it has the materials, the labor, and the variable overhead. And we also have fixed overhead in here. And so we'll put the standard amount of each of those times the rate and get a total in each of those areas. So here we see how much material and the cost per pound of material. How many hours of labor. Now, in this case, we've got 2 different types of labor. So notice there are 2.75 hours at $11 per hour. And then we've got 4 hours at $15 per hour. So we'll have to multiply those separately. Then we've got a variable overhead rate, $5 per labor hour, and a fixed overhead rate, $3 per labor hour. So let's think about that part for a second. When we're calculating the overhead, what is the total amount of labor hours? We'll multiply the overhead rate by. What was that?
6.75.
Correct. Because we have 2 different types of labor, we need to add them together. 2.75 plus 4. So that 6.75 is our total number of labor hours. That's what we're going to multiply by 5 to get our variable overhead, and then by 3 to get our fixed. Okay? So go ahead, take a couple minutes, see if you can come up with the direct material cost per unit, the labor cost per unit, and the overhead cost per unit. Okay, I recommend that you format it like that. Calculate each one separately, and then we add them all together. Anybody have a grand total yet per unit? What'd you get?
165.25.
165.25. Okay, did anybody else get a grand total? Well, let's go through it together. And let's see, probably a table would be useful. Let me think of it. 1, 2, 3. I think we need 4 columns, a whole bunch of rows. Make a table, I like that. Okay. We'll start with our direct material. There's to be the standard amount, or I'll put quantity. Be consistent. Because that's the term that's used in the chapter. So the standard quantity, the standard price, or if we're talking about labor and overhead, it's a rate. And over here we'll have a total. Okay. So direct material, how many units of material? 4. Okay. And this is one of those things that we need to be aware of. Units of product is different from units of material, right? So you don't want to get that mixed up. We're talking about making 1 unit of product, but we need 4 units of material, and this material is measured in pounds. Okay? So a pound of material is 1 unit of material, but we need 4 of them to make 1 unit of product. What is our rate of material? $5.25, and what does that come out to? $21, right? Okay. Then again, we have 2 types of labor. We have assembly, and that takes 2.75 hours, right? At $11 per hour. What does that come out to? Have that? $30.25. Okay. Then we have finishing labor. Okay, and that is not labeled. Funny sometimes what the fingers type, you know, not necessarily what the brain thinks. So we said 4 hours at $15, right? And that comes out to $60. Right? We could total those up if we wanted a subtotal of labor. It would be $90.25 of labor costs per unit. Then we get our variable manufacturing overhead, which is, it's based on labor hours, right? And we said there were 6.75 labor hours. Right? Fine. So we multiply that by $5 for variable. What does that come out to? $33.75. And then our fixed manufacturing overhead has a per unit rate of $3. What is that? $20.25. Okay, great. And then we could add it all together, and we'd have grand total. Okay, 21 plus 35 plus 60. 33.75, 20.25. I think that's what you said, Jordan, right? 165.25. Okay. So that would be our standard costs for 1 unit of this product, bicycle, would be 165.25. All right, so that's what a cost card might look like. But we haven't looked at variance, right? We're not comparing any actual costs at this point. We're just establishing what are the standard costs. Okay. Does anybody have any questions about these calculations or anything? Oh, am I recording? If I am or not. I am, okay. Okay, great. So let's see what's next here. Oh, yeah. All right, so you work for this ice cream company. And the ice cream company brought in a consulting firm. Oftentimes companies will use consultants to help them figure things out. And they're trying to figure out what should be the right amount of production. And the consulting firm came in and said that the company should be able to make 100 gallons of ice cream every 45 minutes. 100 gallons every 45 minutes. And these are the experts, supposedly. But then the management disagreed. They think that to make 100 gallons, it shouldn't be 45 minutes, it should be 55 minutes. So the first question, why is the company establishing a standard in the first place? Why do we even need standards? Yeah. So you have something consistent that you can measure your performance against and see how you're doing, right? There's a saying, something like, what doesn't get measured doesn't improve, something like that. And I think there's some truth to that. If you don't measure what your standards are supposed to be, how do you know if you're improving? The second question, what are some factors the company may need to consider before selecting one of the proposed standards? So if management is saying it should take 55 minutes, and the consultants think it should be done faster in 45 minutes, who do you think is right? The experts or the managers who are directly overseeing the production? Okay, so management might be right because they're the ones that are there overseeing the production, and maybe they have their valid reasons to believe it should take 55 minutes, not 45. It could be they might be thinking of safety, they might be thinking of product quality, they might be thinking our employees are going to complain if we push them to work faster. Who knows, right? Or maybe the managers are just slackers themselves and they don't want to work any harder. We don't really know. They didn't give us enough information. These consultants, maybe they have done this a million times for a million different companies and they know what they're doing and they are right. You know, we don't know. God bless you. So if you are, let's say, CEO in this scenario, who are you going to listen to? Which pros? The internal pros or the external pros? And there's no right answer here because, again, we don't really have enough information. But I could tell you, if you listen to the consultants and you don't get the managers on board, probably not going to work out real well, right? You could change the standard, but they're going to be kicking and screaming, and their employees that are doing the work are also not going to be very motivated because their managers aren't motivated. But if you can convince the managers that, hey, we can do this, there's a way we can speed up production. If they buy into that, then there's a greater chance that you actually improve. Okay, so as I mentioned to you in this chapter, we're going to be comparing standards and actual performance. We're going to do that with materials, with labor, and with variable overhead. Fortunately, the formulas that you use for all three are the same. The words change a little bit, but the formulas are the same. And every formula we have two versions of. We've got basically a long form version, like you see on top, and we've got an abbreviated short form version, which you see in the bottom. For the most part, we're going to be using the longer one because I think it's clearer and easier to understand. I can tell you there's at least one problem that we're going to go through, probably on Wednesday, where we're going to have to use some of the shorter formulas. But for the most part, we'll use the longer one. So don't feel too overwhelmed. You'll have the textbook, you have these formulas to refer to as you need them. The main thing is that you understand the basic concept and how to apply the formula. And then you can look up each formula as you need it, okay? So we're going to start with materials. We'll get to labor and overhead later. Now, there are two types of variance. If you think about the cost cards that we made, we were identifying how much material, like coffee, goes into a cup, and what is the price for that material, right? So there's the quantity and there's the price. And we can have variance with both of them. We might find that our workers are putting too much coffee in each cup or not putting enough. So that would be a variance of the quantity. But then we might find that for some reason, the price we're paying for the coffee is either higher than the standard or lower than the standard. So we can have price variance as well. Once you calculate your quantity variance and your price variance for materials, you can add them together and you get your total variance for the materials, okay? And the same concept will apply for labor and overhead. So you figure out your price variance, your quantity variance, you add them together, you get your total variance. All right, any questions so far? All right, so let's see how this works. Your direct material price variance formula. We're taking the actual quantity of material that was used times the actual price that was paid for that material. And we're subtracting from that the actual quantity times the standard price for the material. Right? So really, what we're comparing is the difference between the actual price and the standard price. And that's what you see down here in the simplified version, the shorter form version of the formula. Actual price minus the standard price times the actual quantity. You can use either of these formulas, you get the same result. It's just two different ways of doing the calculations. This one takes a little longer, but I think it's easier to understand. So that's why we're going to use mostly that. So this is how we do our direct materials price variance. I think we have an example here. We do. So this candy company is making candy, obviously. We need to figure out direct materials price variance. That's what we were just looking at here, right? They are using here the simplified version. So that's fine, we'll use that for now. And that's taking the actual price per unit of materials, not unit of product, right? Unit of material, minus the standard price per unit of materials, and then times the actual quantity. So let's find that information. It says here the actual price was $9 per pound for materials. Notice that $9 is here. The standard price is $7 per pound for materials, and that goes here. So the difference between the actual and the standard is $2, right? And then we're multiplying that by the actual material that got used. Notice it says they actually used 1/2 pound of material per box. right? So that goes there. So then we just take that $2 difference times the half pound of material per box. That gives us a rate of $1. That's how much variance we have compared to the standard price. Because we're paying 9 instead of 7 per pound of materials, right? For some reason, we're paying a higher price. So that $1 extra it's costing us per box or per unit of product is unfavorable because we're paying more than the standard. Okay? That's the basic concept that we're going to be doing over and over today. Now, they also told us that the standard amount of pounds of material was 0.25, but we didn't need that for this formula, right? There's nothing here about standard quantity. That's going to be used when we figure out the quantity variance. Right now, we're only trying to figure out the price variance. Okay. So any questions so far? Yes, Jahira.
What was the variable amount?
What would the variable?
The variable amount? Because right now it's $1, it's unfavorable.
Yep.
The favorable.
Oh,
We
well,
want that at a certain dollar amount.
yeah, okay, so, well, okay. Here's another way to think about it. If we were to use the other formula, we said actual quantity times the actual price, right? The actual quantity is half a pound of material. And the actual price was $9, right? So it's actually costing us $4.50 per box for materials. And the other part of the formula, actual quantity times standard price, we took that actual quantity times the standard price, that would be $3.50. So what we're saying is it's costing us $4.50 per box. It's only supposed to cost us $3.50. So we're paying an extra $1 per box, which is unfavorable, just because we're paying a higher price for materials. Okay? Yeah.
So would a favorable one be negative?
Yes. If the answer was not unfavorable, but if the answer came out favorable, then yes, it would be a negative number. Yeah. Is that what you meant?
Yes.
Oh, okay. And we'll see examples of that. All right. Okay, let's look at this one. You run a fabric store. Our direct materials price and quantity variances are both unfavorable. Okay, that means we're paying more per unit of materials than the standard, and we're using more materials than the standard. So why might that be? Let's start with the price we're paying. Why might we be paying more for materials than our standard?
Maybe the more that you're paying, it's like better quality.
Okay, maybe we switch to a different type of material that's a better quality and costs more, perhaps. What else? Well, why else might we be paying more than normal, more than the standard for our materials? Inflation. Yeah, very good, Miranda. That happens, right? Suppliers might raise their prices. Or maybe we normally buy in large quantities and get a discount, and this time we bought in a smaller quantity. Or maybe we didn't pay in time to get a discount for paying early for our purchase. So we don't really know, but those could be some of the different reasons our price variance might be unfavorable. What about the quantity variances? Why might we be using more material than the standard? Okay, maybe we've got a worker who's not doing a very good job and they're using more material than should be necessary. That's very likely. What else?
It could be some type of machine that's not working right.
Okay, machine's not working right. Maybe this material that we're getting is harder to work with than what we're used to, right? So there could be various things going on. Now, if our price variance is unfavorable and our quantity variance is unfavorable, and we add them together, the total variance is also going to be unfavorable, right? Okay. So let's look at quantity variance. Now, this is similar, a little different. In this case, we're taking actual quantity times standard price and subtracting standard quantity times standard price. So here the difference is between actual quantity and standard quantity. If we compare that with the other formula for price variance, actual quantity was the same in both cases, right? But we saw a difference between actual price and standard price. And notice this right-hand part of the formula, actual quantity times standard price, is the left-hand side of this formula, actual quantity times standard price. And then we're subtracting from that the standard quantity times the standard price. Once you get used to these formulas, they're pretty easy to use. The harder part, I would say, is sometimes in the exercises and problems, you're trying to figure out, okay, what is the actual quantity or what is the standard price? And sometimes that information is not given to you and you have to figure it out, right? And that's why this chapter gets tricky. But once you get used to these basic formulas, they are not so bad. Again, we've got a simplified version. Let's go ahead and apply this. I think we're back to the candy company here. Same data, exact same data we were working with, but now we're looking at quantity variance, right? Before we were looking at price variance, now we're looking at quantity variance. So what we're going to do, here in the simplified version, we're taking the actual quantity minus the standard quantity. And then we're multiplying that by the standard rate of $7 per pound. Right? So what we're saying is we're supposed to be using a quarter pound of candy per box. For some reason, we're putting a half pound. That's a pretty big difference. But for some reason, that's what we're doing. So we're using a lot more material than we're supposed to. And the amount that we're using in excess times the standard rate comes out to $1.75 of extra material per box. Jordan?
You can already kind of tell when it's favorable or unfavorable, like before using the equations,
Mhm.
just from what's in that, right?
Exactly.
More.
Anytime your actual is more than the standard, you know it's going to be unfavorable. And anytime the actual is less than the standard, you know it's going to be favorable because you're saving money, right? So yes, that's exactly right. Okay, so any questions here? All right, then to get your total variance, there are two ways to do it. I usually do it the easy way, which I think is more efficient. Here's the harder way. Harder way would be this formula. Actual quantity times actual price minus standard quantity times standard price. You could do it that way. I can't think of any situations where you have to do it that way. In the whole chapter, there might be one or two. But for the most part, I find it easier to do it this way. Once you know your price variance and your quantity variance, you simply combine them. And that gives you your total variance. To me, that's easier than having to do a whole another formula up here. I will tell you though, it gets a little tricky if One of them is favorable and one's unfavorable. Because then you're adding a positive and a negative number, and then you have to make sure you know, is the result positive or negative? Okay, but we'll come across that later. In this case, they're both unfavorable, so all you do is add them together. Price variance was $1, unfavorable. Quantity was $1.75, unfavorable. So the total cost variance per box of chocolates is $2.75 in terms of materials. Because we're using too much material, paying too much for the material. Okay? All right. Oh, now these are helpful to kind of see how it all flows together. If you look at these two boxes here together, that is your price variance formula. Actual quantity times actual price, and then just imagine a minus sign here, minus actual quantity times standard price. That gets you your direct materials price variance. Same formula we saw earlier. And then the quantity variance is these two boxes together. Again, same formula we saw earlier for quantity variance. It was actual quantity times standard price minus standard quantity times standard price. That gets you your quantity variance. And then you just add these two together, price and quantity, to get your total variance. Okay, so this might be a helpful graphic to see those relationships and see what's going on. Okay, any clarification needed? Comments, questions? All right, well, okay, yeah, let's try this one out. Okay, so you'll solve this one on your own. So this company makes shampoo. Their standard material cost is based on 8 ounces per bottle and 85 cents per ounce of material. Okay. They made 11,000 bottles. So that's the actual production. But in this case, we're going to have to compare that. We're going to have to figure out what's the actual amount of material that they used. Actually, we don't have to figure it out because it tells us they used all 89,000 ounces that they bought. So we know their actual quantity was 89,000 ounces. And the actual cost was 74,760. We have to figure out first the price variance and then the quantity variance. So using those two formulas, figure that out. What's the price variance? What's the quantity variance? All right? So I'll give you all a few minutes to work on that. For those who just came in, you might be completely lost. Maybe the person next to you can help fill you in on what's going on and show you how to solve it.
See, I never heard of that.
Anybody get the material price variance yet? No? Okay, give me another minute or two.
Yes, I say man. I already. Oh, you. You feel that? Okay. Yeah.
All right, so who's got the material price variance? Nobody? You got it right, Joe? You don't have it? It helps to use these little boxes that are in the exercise and problem sets. I'm gonna go ahead and put a couple right here. Again, takes a little while sometimes, but I find using these boxes and using that long form formula is just a lot easier to understand and make sure you're doing it correctly. So let's do it like this. I'm gonna write the formula in here. And then I'll have you all help me solve it, okay? So we're gonna start with the price variance. And the formula goes like this. It's the actual quantity times the actual price minus, just imagine a minus sign there, actual quantity times standard price. Okay, that's gonna be direct material price variance. And then the next formula is going to be our direct material quantity variance. And that one, again, the left side of this formula is the same as the right side of the price variance formula. And then we're going to subtract standard quantity times the standard price. Okay? Those are the formulas we'll be using over and over and over. Just those two formulas. We're going to sometimes use them for labor, sometimes use them for overhead. But this is the majority of what we're going to do this chapter. Okay? So now that we have this kind of framework for our two formulas. Just fill in the numbers. And then I'll show you how we do our calculations. What is the actual quantity of materials that the company used? Okay, Jordan's correct. He says 89,000. Now, in this case, they bought 89,000 ounces of material. That doesn't really matter. We don't care how much they bought. We care how much they used, right? But it says that all 89,000 ounces were used. So that's why we're going to use that number. That's the actual amount of material that they used. So we'll put 89,000 as the actual quantity. And you might have noticed there are 3 different places to put that. Okay. Every place where I had actual quantity, we put 89,000. Does that make sense so far? Okay. Then we need to know what is the actual price they paid per unit of materials. Well, what is that answer? What is it? 0.84. Did anybody else get that? 84 cents per ounce. How did you get it, Jordan?
Use, 7.765.
Okay. So in this case, they didn't give us that number. They told us the total cost of the material. And like Jordan said, you might not have heard him, but if you take that total cost and divide it by how much material they bought, it's 84 cents per ounce. So that's the actual price they paid. There's only one place that we put that here. Okay, does that make sense to everybody? Sometimes they don't give you the information, so you have to figure it out. Total cost, what they actually paid, minus the actual ounces they used, gives you an actual price per ounce. Okay, what are we missing now?
The standard price.
Standard price, exactly, Alexandra. And what is the standard price for material? 85 cents. That they did give us. Okay, and again, there are 3 places we can put that. So that 85 cents goes there, it goes there, and it goes there. If there's one thing left that we need, what is that? Exactly, Audrey's right, standard quantity. Oh, am I recording? I am. I recorded those minutes that you were working independently. You all let me do that. Thanks a lot, okay. Guess I need to pay more attention now. Okay, so I apologize to anybody watching this recording in the future. I'll try not to do that again. How do we figure out what is the standard quantity of materials for this amount of production? How much should it have taken us to make this many bottles? What did you say, Audrey?
8 ounces times 85 cents times 11,000.
So 8 ounces, because we're only talking about quantity at the moment. So it's the 8 ounces times the 11,000 bottles. Because we already have the 85 cents down here, right? So the standard quantity is 8 ounces per bottle. And since we're making 11,000 bottles, that would be a total of 88,000. Your standard quantity is always based on the standard quantity per unit times the number of units that you make. So what is the standard quantity for this level of production? It's 8 ounces times 11,000 bottles that we produced. 88,000 is our standard quantity. Okay, great. Now that we have all of our numbers in there, it's just a matter of crunching the numbers. So 89,000 times 84 cents. 74,760. Again, that was our actual quantity times our actual price. And actually, that makes sense, right? Because they already told us it was 74,760. And then the standard would be 75,650. For that level of production, based on our standard price, it would actually be a bit more, right? Because our standard price is 85 cents. We only paid 84 cents per ounce. So now what you do, the last step, is you take the left side, subtract the right side. 74,760 minus 75,650, we get negative 890. What did I say about negative numbers for this chapter? They're favorable. Exactly, right? We saved $890 on materials because we got a cheaper price per unit of materials. So I'm going to write that up here, 890 favorable. Right? Any questions on this price variance? So let's go to the quantity variance. Well, we already calculated 89,000 times 85, right? That already came out to this. Now we have to calculate 88,000 times 85 cents. 74,800. And we're going to do the same thing we did last time. We're going to take the left side, subtract the right side. And that gives us $850. That is a positive number, so that's unfavorable, correct? Okay, so our quantity variance is 850 unfavorable. Okay, so we have completed that process, but let's take it a step further. If we wanted to know our total cost variance for materials, what would it be? $40 favorable, yes. So again, you can look at it a couple different ways. You could just say price variance, which was negative 890. Actually, I should probably clear that out. Negative 890 plus positive 850 leaves us with negative 40. We know negative is favorable. So yes, you're right. Or another way, if you just take the difference between 850 and 890, that's a difference of $40. And then you think which one was higher? The favorable was the higher number, so my answer is favorable. Whichever way makes more sense for your brain is fine. You either combine them or find the difference between the two. Okay, very good. Any questions? Okay, so then, oh, we have an exercise. Let's do the exercise, number 6. Okay, so again, we see those boxes. Those are going to be pretty useful there. First thing we need to do, figure out what is the standard price paid for materials. I think this is taking it a step further. Yeah. I'm trying to think, are we ready for this? I don't want to get you all confused. I think we'll skip this exercise for now. I don't know. Are you up for a challenge? Is You don't seem very enthusiastic. Okay. Let's do it. Okay, let's do it. But I want to make sure, are there any questions about what we've done so far? We took those two formulas, direct material price variance, direct material quantity variance, we plugged in the numbers, got our totals, combined them together to get a total cost variance. But any questions about what we've done so far? Okay. Well, let's tackle this one then. What's different here is they didn't give us all the information. Well, they didn't do that the last time, but that information wasn't that hard to figure out. This one is a little more challenging. So the first thing we have to figure out, what is the standard price paid for materials? Okay, they told us the actual price paid per pound of material, right? They told us total standard pounds. This is the quantity, right? The standard quantity. In fact, let's do this. I'm going to put here, this is the actual price. This is the standard quantity. Pounds of material used. That's the actual quantity. And then they gave us the direct material price variance, which is favorable. But they didn't tell us the standard price. We have to figure that out. We can use that same box, that same table that we just used. We're just going to use it differently. So I'll tell you what, let's fill in the formula to start with. Actual quantity times actual price minus actual quantity times standard price. That is our formula for the direct materials price variance. Okay? And let's see what we know. What is our actual quantity of materials?
I thought it was 32.
Yeah, 13,250 is the actual quantity, right? That's what we actually used. So that's going to go here and here. Okay, what is the actual price we paid for materials? $14.50 per pound. That's right, $14.50. Okay, but standard price, that's the thing we don't know. So we're gonna have to figure that out. Now, the other piece of information they gave us, the clue here, is they gave us the direct materials price variance. That's what goes here. And because it's favorable, we know it's negative. So let's go ahead and plug that in, 4,637.50. Okay, that's the information we have. So if we need to figure this out, the way we're going to do it, we're going to start over here, calculate that number, then based on the variance, figure out what this number is, and then we'll be able to figure out the standard price. So we're kind of backing into it, okay? Any questions before we do that? All right, so again, we have to start over here because we have that information. So we're going to take the actual quantity times the actual price, $192,125. All right. Now we have to think about this next part. Remember that when we use this formula, we take the left side minus the right side to get our variance. So if when we do that, we get a negative number, then is this missing number, is that going to be higher or lower than what's on the left side?
Or,
Going to be higher,
I,
right? Because remember, we're taking this number, we're subtracting what's on the right. So if it's something larger, that will give us a negative result. So that's what I mean about this chapter. You kind of have to think backwards sometimes. And what that means is if we take that number on the left, we add the 4,637.50 as a positive number, we get the higher number on the right, 196,762.50. Okay, so now you can see if we took that number on the left, subtract the bigger number on the right, we would end up with this negative result. Now there's one step left. How can we get from this to our sales price per unit of materials? Divide. Yeah, we're going to divide it by the 13,250 units. And when we do that, we get $14.85. So that is our standard price per unit. The way I recommend you do this is when you use one of these tables like this and you calculate your answer, put the answer up above it too for reference, right? Because what is the standard price for materials? Now you know the answer was $14.85. Because we weren't looking for this, we already knew that, right? In this case, what we were looking for was this one. Okay, any questions here on part A? All right, let's go on to part B. What is the direct materials quantity variance? So here we're using the second formula. And if you remember, the right part of the price variance formula is the left part of the quantity variance formula. So we could save ourselves a little time by just taking the right part of price variance and make that the left part of quantity variance. But then what we need over here is standard quantity times standard price. Well, the standard price is what we just calculated, right? The $14.85. And the standard quantity was this one, 12,500. That's the normal amount of material we would use for this level of production. Okay? So this is pretty straightforward. Now we're just going to do the calculations. That comes out to 185,625 over here. What's our next step? Subtract, exactly. Take the left side, subtract the right side. We get 11,137.50. Okay. Is that favorable or unfavorable? Unfavorable, because it's a positive number, right? That means we spent more because of the extra quantity. I'm going to put my answer up here. 11,137.50, unfavorable. All right, any questions on the quantity variance? Okay, well, C asks us for the total direct material cost variance. So again, we can just combine them together, right? I could take that positive number we got, I could subtract the favorable amount. Our difference is $6,500. Is that favorable or unfavorable? Right, because our unfavorable was larger than the favorable. So when we subtract it, we end up with still an unfavorable amount. So our answer here, the total cost variance is $6,500 unfavorable. Okay. The last part says if the direct materials price variance was unfavorable, because remember it was favorable. So they're saying if that were an unfavorable number, then what would be the standard price? Now what we have to do is basically repeat what we did in A. The actual quantity and actual price are still the same. But they're saying instead of this being a negative number, what if it were unfavorable? It would be a positive number, right? So then what would be our standard price? Okay. So we took our actual quantity times actual price. We get that number. And then we have to figure out what this number is. Right? What number would it be if we take the left side, subtract this missing number, and we get this positive number?
187,487.5.
That sounds right. And how'd you get that, Alexandra?
Take the left side, subtracted it from our
Exactly. We took the left side, we subtracted the variance. That gives us this smaller number, right? Because remember up here, we had to take the left side and we added that variance to get the larger number. This time we had to switch it around. Then what would we do next? Divide. Exactly. So we're going to take that result. Oops, I think I wrote it wrong. Is that what you got, Alexandra? 187, 487.50?
Yeah.
Okay. Yeah, we're going to divide that by the 13,250 actual quantity. And that will give us our new standard price, $14.15. So that is our answer for D, $14.15. A lot of steps. And they like to mix it up on us, so they're really checking to see if we understand what we're doing here. Is there anything you would like any clarification on this exercise? No? All right, well then, let's go on to labor. Again, it's the same. The formulas are the same. Only the wording is a little different. So in this case, we don't have a price variance. You don't pay a price for labor, you pay a rate, right? You pay people whatever their rate is. Okay, so different word, but same concept. The quantity would be the number of hours worked. So the actual hours times the actual rate minus actual hours times standard rate. Exact same formula, right? Just different words. And then again, we have a simplified version down here. I think, yeah, we're back to the candy company. So let's apply this process. Let's figure out what our rate variance is for labor. Okay, so it says the standard rate per hour is $8. And notice that standard rate is here. The actual rate that we paid is $9.50, which goes here. And as Jordan pointed out earlier, just based on that, if we know we're actually paying more than the standard, we know it's going to be an unfavorable variance, right? So we take the difference between the actual rate and the standard rate, which is $1.50, multiply it by, let me think, the actual quantity, which is, where is it? Ah, it's over here. The actual labor is 0.2 hours, right? That's the actual quantity, and that gives us our rate variance. And as we see, it is unfavorable. So we're spending an extra 30 cents per unit of product. Yeah. Because we're paying a higher rate, okay? Time variance is like the quantity variance. Same concept from materials, we're just, instead of quantity, we're calling it time. So we're taking actual hours times the standard rate minus standard hours times the standard rate. Same data here. Okay, again, the actual time it took was 0.2 hours per box. The standard is 0.1 hour per box. That's a difference of 0.1 hours per box, right? Times the standard rate, that's 80 cents unfavorable. Because for some reason it's taking our workers longer to make the candy. But really, it's the same concept, right? Total works the same way. You could use the longer form version, or you could just take your rate variance plus your quantity variance, add them together. Just like before. And then again, you can see the relationships here. This box minus this box gives you your rate variance. This box minus this box gives you your time variance. Combine them, you get your total variance. Okay, but once you get those first two formulas down, that's the hardest part. Well, not the hardest part. That's the part we're going to use most frequently. All right. Any questions here on the labor variance? Okay, another exercise. This one is not hard. There's nothing tricky about this one. They give you all of the information you need. It's just a matter of plugging the information in and doing the calculations. So it's exercise number 12. Here we go. And again, they tell you actual price and standard price, actual quantity, standard quantity for materials. Actual labor rate, standard labor rate, actual hours, standard hours. Nothing tricky. So what you're going to do is fill in, again, the way I would do it, in fact, I can go ahead and put them in there right now, is put in your formulas, then just replace the letters with the actual amounts, and then do your calculation. So again, the formula goes like actual quantity times actual price minus actual quantity times standard price. That formula repeats over here. And then you subtract standard quantity times standard price. Down here, it's going to be actual hours times actual rate minus actual hours times standard rate. Again, that repeats on the left side. And then you subtract standard hours times standard rate. So let's all start here with materials. I go like, I'll make it a little smaller. Almost fits. Okay. So go ahead and work on the material price and quantity variances. Had a gold star. Okay. So actual quantity is 100 of materials. Yeah. So that goes in 3 places here. Then the actual price is $1, right? That goes right there. Standard price, $1.20. You see 3 places for that. And standard quantity is 110. Right? So that means we have $100 here, $120 over here. And when we subtract, we get negative $20. Am I right? Okay, so we have a $20 favorable variance, right? For material price. Okay, then we go on to material quantity variance. Well, remember, the right side up here for price variance is the same as the left side on quantity variance. And then over here, what does that come out to? 132? $132. We subtract the left side minus the right side. We get negative $12, right? And so that's $12 favorable. Any questions so far? Then we go down to our labor, okay? Actual hours is 200. Again, it goes in 3 different places. Actual rate is $15. Standard rate is $16. That goes in 3 places. And standard hours is 220, right? Yeah, okay. Then we do our calculations. We get $3,000 over here, $3,200 over here, subtract, and we get negative $200. So our labor rate variance is 200 favorable. Then down here, again, this is duplicated over on the left side. And what does that come out to? 3,520. Okay, we subtract, we get negative $320. So we have a $320 favorable efficiency variance because our workers are working at a faster pace. They're getting more quantity done than the standard. Okay, so we've done our calculations for A. Notice they all came out favorable, right? That's good. Now we have to think about what could cause that. What could cause the price that we pay for our materials to be lower than usual or lower than the standard? We used less material than the standard. We paid a lower rate to our workers than the standard, and they used less time than the standard. Some fairy came down and waved a magic wand and made everything amazing. How could that like really happen? How could you explain all those favorable variances? Any ideas? Okay, maybe we bought in a large volume of materials and we got a lower price. That would explain the price variance, right? But we still have a lot of unanswered questions. Okay, so here's a possibility, and you might want to jot down something along these lines. It could be any number of things, right? And maybe they're not even related. But if we're looking for like one magic answer, it could be that we purchased materials that were both cheaper and higher quality. The higher quality allowed the employees to use less material, less labor, and I have to make that a separate sentence. We'll just say and less labor. Also, because the material was easier to work with, we could hire employees with fewer skills. Did you put your name on the list?
Oh, you
You did, okay. At a lower rate of pay. Okay, so we found some magic materials that accomplished all of these things. It could happen, right? Some new technology comes out, some amazing material saves us money all the way around. It's possible. Questions or comments? All right, looks like it's break time. So I'll see you all in 10 minutes.